To stay the most powerful country on Earth, a nation must dominate every environment: land, air, space, and especially the ocean. And for the United States Navy, the core symbol of that power is the aircraft carrier. But by the end of the 20th century, even America's mighty carriers were starting to look outdated. Technology was changing fast, threats were growing, and the old design philosophy was reaching its limits. So the Pentagon decided it was time for a new era. That's why in 1996, the US launched a project for a next-generation carrier. It was called CVN-21, literally the aircraft carrier of the 21st century. Later, the program became known by the name of its first ship, the USS Gerald R. Ford. The name itself already showed what the Navy wanted: a ship that would represent a new generation of American sea power. The original requirements were ambitious, almost crazy. The Navy wanted a carrier with at least 100,000 tons of displacement. It needed to be huge, but also smarter and more modern. It needed a longer, more efficient flight deck. It had to handle all current aircraft used on Nimitz-class carriers, and also any future prototypes. But the second key requirement was even harder. Operating costs had to drop by at least 20%. The engineers got to work. Very quickly, design teams created multiple revolutionary concepts. Some of these early drafts looked like science fiction. They resembled ocean versions of Star Wars battleships: clean shapes, futuristic towers, strange deck layouts. But then the admirals saw the price tag, and reality hit like a hammer. If the Navy tried to build 10 fully futuristic stealth carriers, they would bankrupt themselves. No one wanted to explain to Congress why the Navy suddenly needed money for spaceships. So, the leadership changed the priorities. They quietly removed the stealth requirement and focused mainly on what mattered politically: lowering long-term operating costs. So, what did the Gerald R. Ford actually become? First, the Navy decided to keep the basic hull design of the old Nimitz. That might sound boring, but it was the safest move. The hull was only slightly modified, mainly to reduce radar signature. That means the Ford-class carrier is still similar in size to its predecessor, about 1,105 feet long, roughly 250 feet high, and 255 feet wide at its widest point. In other words, it is still a giant metal monster, big enough to shock anyone who sees it up close. However, the layout above the deck was changed. The superstructure, the island, was redesigned. The command tower was moved farther back toward the stern. The captain's bridge was moved to a lower position, which helped reduce the total height and radar profile. Many rooms, offices, and cabins were moved into the hull. The island itself became smaller and more compact. The mast was built using composite materials designed to absorb radar energy. Obviously, you cannot make a 100-foot warship invisible, but on some radar systems, especially those used by cruise missiles, it could now appear more like a normal escort ship rather than a huge carrier. And that creates a dangerous question for an attacker. If several ships look similar, which one is the real carrier? Missiles do not have human eyes. They can't guess. So reducing signature doesn't mean invisibility, it means confusion. Second, Ford-class carriers got a major upgrade in power systems. The ship uses 2 new A-1B nuclear reactors. These reactors can generate around 25% more electricity than previous reactor types used on older carriers. Even more impressive, they are designed to operate for about 50 years without refueling. That means the carrier can remain operational for decades without the deep reactor refueling process that older carriers required. These reactors power everything: engines, sensors, weapons, electronics, and they can push this 100,000-ton beast to around 30 knots, which is roughly 35 miles per hour. In World War II, that kind of speed was normal for fast torpedo boats. Now we're seeing it on a floating airport the size of a small city. Third, Ford-class ships were built with much heavier automation. This is where the Navy hoped to save money. Automation reduces manpower, and manpower is expensive. Thanks to advanced systems, the crew is reduced by about 1/3. A typical Nimitz-class carrier might carry over 5,000 people when you include the ship crew, flight deck crew, and command staff. The Ford was planned to run with about 4,600 personnel total. That sounds like a huge win. Over a carrier's lifetime, manpower and operation costs can reach around $20 billion. So if the Navy truly saved 20%, the savings would reach $4 billion per carrier. Multiply by 10 carriers and you get $40 billion. That's an insane number. But let's be honest, those savings are not as impressive as they sound. Spread across 50 years, that $40 billion becomes around $800 million per year for the entire fleet. In Pentagon terms, that is not a miracle. That is a rounding error. And spoiler alert, the savings may never even happen because new systems bring new costs. Now let's talk about the real purpose of an aircraft carrier: combat power. A carrier is not built to look strong. It is built to launch aircraft. And the Ford class does that in a terrifying way. Thanks to its large deck design, the ship can carry up to 90 aircraft depending on the mission. This includes modern F-35C stealth fighters, F/A-18E/F Super Hornet strike fighters, E-2D advanced Hawkeye early warning aircraft, and MH-60 helicopters. And that doesn't even include the unmanned aircraft that will likely appear in the future. To understand the strategic impact, there are fewer than 100 F-35S in all of Europe if you exclude US. Stationed aircraft. So, one Ford-class carrier alone can project power across an entire continent. Against any enemy except Russia or China, this ship is not just a weapon. It is a diplomatic final argument. Even more important is sortie rate. The Ford-class carrier was designed to launch aircraft faster than Nimitz-class ships. The goal was about 15% higher launch efficiency, and it achieved this even though it has only 3 catapult tracks instead of 4. How? Because the Ford doesn't use steam catapults. It uses electromagnetic catapults, EMALS. These systems can reset faster than steam systems, can launch aircraft in a smoother way, and reduce stress on planes. The ship also received a new arresting gear system for landings. With these upgrades, the Navy claimed the ship could generate 160 sorties per day, and in extreme combat situations, up to 220. That is a massive number. But there was a problem. Actually, there were many problems. During testing from May 2017 to January 2019, the EMALS system recorded 20 failures during 740 launches. No aircraft were destroyed and no crew members were killed. But failures still shut down operations and interrupted flights. Later, engineers discovered EMALS could only support about 400 launches before malfunctioning, far below expectations. The arresting gear system had issues too. Instead of handling long cycles reliably, it showed limits far below the planned performance. And even worse, the ship's new electromagnetic weapons elevators were unfinished. 11 elevators were designed to move bombs and missiles from storage to the flight deck quickly. But by late 2018, most were not working. Only 2 were repaired early. The rest required redesign and fixes even after the ship was officially commissioned. So, what caused all this? Software. Yes. The biggest weakness of this future carrier was not metal or engines. It was computer code. And that leads to the most painful result. This carrier was supposed to save money. Instead, it became the most expensive warship in human history. The ship alone cost $12.8 billion. Another $4.7 billion was spent on development. Even if that development cost is divided across future ships, the final price is still over $13 billion. That is a shocking number for a carrier that struggled just to launch planes reliably. In terms of defense, the Ford itself carries systems like ESSM missiles and RAM launchers for close protection. It has advanced radar like the dual-band radar system. But its true defense is the escort fleet: cruisers, destroyers, submarines, and aircraft. that is how modern carriers survive. Construction officially began in 2005 with a major ceremonial steel cut. The next ship of the class is the USS John F. Kennedy, and more ships will follow over time. The final planned ship might not appear until 2058. So how has the Navy used this powerful new carrier so far? The truth is, it hasn't. Since commissioning, the Gerald R. Ford has not fought in any real war. Instead, it has been stuck in long testing cycles, system troubleshooting, and repairs. There are few public reports of major exercises. One famous test happened in June 2021, when the Navy detonated a massive underwater explosion near the ship as part of full ship shock trials. The blast was similar to a 3.9 magnitude earthquake. It was meant to test whether the ship could survive real battlefield damage, but even after that, the ship still faced technical issues. And here is the final irony. The older Nimitz-class carriers cost about half as much. The Ford is twice the price, but its combat efficiency is not twice as strong. Even in theory, Nimitz can generate around 120 sorties per day. Ford's target was 240 to truly double combat output. But even the Ford's maximum of 220 can't reach that. And in reality, system reliability could reduce numbers even more. So, what do we get? A carrier that represents the future, but also proves the danger of overcomplicating military engineering. A ship that costs more than almost any weapon system ever built. And a question that is still unanswered: is the Gerald R. Ford class worth it? Or is this a perfect example of how modern military projects become too expensive, too complex, and too difficult to maintain, even for the richest country in the world? Now it's your turn. Do these third-generation carriers justify the money already spent and the massive funding still planned for the future? Or could that money be spent in a smarter way? Write your opinion in the comments. And don't forget to like the video, subscribe to the channel, and turn on notifications, because more stories about modern weapons are coming soon.